So last Thursday, we talked about this energy resources, and I think a number of things I mentioned. First is over the past 12 to 13 years, the use of coal has been significantly decreased. And in the past, the first time I thought the coal-fired power plant takes the number one energy resources of electricity generation. So it takes 42%, but now it's only 16%. The natural gas is the number one. And the nuclear is pretty much flat. Nuclear didn't change over maybe the past almost like 20 years, 20 to 30 years. But why I want to show this slides again, because there's some news about restart some already retired nuclear units to generate electricity again. One example is the power plant. I believe everybody's heard the power plant, which is called 3 Mile Island, unit number 1, which has been shut down. There's a crisis, a nuclear crisis, long time ago. But Microsoft just signed an agreement with the power plant to restart that unit, to upgrade and restart unit. The purpose is not to generate electricity for general customer, is just to power what we call a hyperscale data center. The hyperscale data center will need power pretty much either same as nuclear power plant, maybe 2 or more nuclear power plant, because the hyperscale data center, usually the power level is about 100 megawatts, but they are talking about a 1 gigawatt low level data center. Just think about 100 megawatt is about the load, that's the major load in Knoxville city center area, because the first power plant, which is the what's the name of that dam? Yeah, Norris Dam. Yeah, but Norris Dam, which is about 40 to 50 miles away from the center of Knoxville. So that power generation about 130 megawatts. Okay, so that is about the size of a typical large data center. But the future data center, we're talking about 1 gigawatt. So that's 7 or 10 times of bigger of a power plant. So that power plant can power the North County, pretty much the customer of North County maybe 90 to 80 years ago. Maybe not today, but that 100 megawatts, it's about the size of a smaller scale, maybe a mid-scale city. So sooner or later, we're going to see nuclear will go up. So there will be 2 types of nuclear. One is some old nuclear power plant. They can be shut down, they can be upgraded. Another will be some, what is it called, like a micro scale or maybe a small scale nuclear power plant. So those power plants can be placed to Nevada State, Texas, far away from any large city. So they have a smaller concerns, but they can power the data center. One news I read about is if you're an international student, you live near Knoxville, you have go to apartment, right? Someone will build that building apartment for you to lease or rent. So somebody try to identify those locations far away from any people, but that one can be on the path of very strong transmission grid. So they can provide very reliable electricity supply. And they even consider to build a new power plant, even it's not very clean, or maybe nuclear. Nuclear is clean, but it has a lot of concern. But they will be okay. Very ideal power plant for data center. Okay, so they start building such infrastructure and invite other company, like not very large scale company, they can lease maybe one building or to build out their data center. But for the large company like Microsoft, Amazon, Web Service, or Google, they want to find their location to build their data center. Okay, so sooner or later we'll see the nuclear will go up, I guess, because today's data center load maybe in the US only take about 1%, maybe 1 to 2%, but pretty soon it will take close to 10% of load, because they predict about 50 gigawatt load maybe next 10 years. So later we'll see what does 50 gigawatt mean to the entire North America power grid. So those two slides that let you know there are some reliability concerns besides any simple math, like a total generation, this number, total load is this number, A is bigger than B, so we are safe. No. So you have to make sure you can deliver the energy safely to the users. That's also not enough. And for this specific course, we care about reliability and security and stability, which consider continuously. Okay. So even you can deliver every megawatt generated from power plant to each individual user, under normal condition, you still need to consider what if you lose the transmission line, what if you lose the transformer. It still has to be safe. So that's about reliability and security. Okay, so we talk about this. So if we partition the any AC power grid into different portions based on the voltage level, so it will be generation, transmission, sub-transmission, and distribution. For this specific course, 522, we focus on generation, transmission, and sub-transmission. Because all reliability standard focus on the high voltage level, not about the low voltage level. Because if you just think about if we continue drawing this figure, right? So it draws into the farm and home, and actually inside of each home you may have a microgrid. The microgrid is also power grid. It has everything. It has all the meters, it has sensors, it has the load, it has controller. Yeah. It has everything. But we have to stop here. So basically, for reliability standard, they only care about maybe the sub-transmission level. So for the distribution level, they will integrate everything under the sub-transmission substation as one single load. So that's why we need to do the modeling for the load. Okay. So when we go to the load modeling section, we'll look into the complexity in this area. So what needs to be considered? This is very useful table, just to educate you about what we call power industry. So when you read any news article talking about power industry, or power company, or utility company, so what do they mean? What do those terminologies really mean? We have to start from this table. Definitely, if you write a paper or communicate with anybody, you can just in general say power company. Okay, I work for a power company. I work with power company. Or my method will benefit power industry. But if the audience asks you what do you really mean by power company, so there are different types of companies which all fall into the general power company. But before we talk about all different companies, we have to narrow down to very specific company, what we call electric utility or utility company. Okay, so any company fall into this table can be considered electric utility company. There are some power companies. They're literally speaking, they're only doing business of power, but they are not utility company. So utility company has to own something of the power grid. Right? You may think that's a very silly question. So I'm a power company. I do business on power. Why do I? Definitely, I need to own something. No, many companies don't own anything about power grid, but their business is power. Okay, we'll talk about that type of company later. But in this table, all the companies need to own something from the power grid. That's why we call them electric utility company. So when I work for Electric Power Research Institute, we have to make it very clear. So when we design the portfolio, a portfolio means you develop some idea of a projects, and based on the cost, you just integrate into different project sets and sell the project set to individual companies. So the price to utility company and to other company are different. Okay, as a utility company, you own something, right? So you need to be priced, maybe higher or lower, but they should be considered different companies. So I have the highway to make it very clear. So I try to make all the sentences I use in my email paper, I try to make it very clear. If I see anyone, even from National Life, they're talking about, okay, I work with this utility company, but actually that's not utility company, I will correct them anyway. Okay, so let's see. So there are based on the data back to that's already old data, that's 30 years ago. Okay, there's 3,000 electric utility or utility company. Fewer than 1,000 engaged in power generation. So less than 1,000 can generate electricity, but others, they cannot generate electricity, but they can deliver, they can distribute, they can do retail, they can do anything else for the electricity. So if we categorize those companies, we see there are 1, 2, 3, 4, 5. But if you try to find any name which are familiar to you, right? So we see TVA, we see Tennessee Valley Authority. So it's the Tennessee Valley Authority. It's not the Time Warner Authority. Right? So it's, nobody knows Time Warner Authority. Really? You are really just a nerd. I recall Time Warner Authority. Nobody heard this name? If you work for that company, you can jump from one time to another time. Nobody watch a Marvel movie. I believe the power student really the nerd of the electric engineering student. Okay. Because when I said, so I have a contract with the Time Warner Authority and everybody laughed. At least maybe half the class laughed in 325. But when you do the PhD study, just open your mind. That's watch any movie, right? Like sci-fi movie. Okay. Tennessee Valley Authority, even the name starts with Tennessee. It's not the Tennessee State Power Company. It's a federal government company. So if you work for TVA, you will be a federal employee. You're not a state employee. Okay. Another two companies is a BPA, which is Bonneville Power Administration. So if you have a project with a northwest area, you will work with that power company. So another is YPOC. So those three actually, the company, why they're federal government-owned company, because their initial project use federal money. It's just like the Norris Dam project, which go back actually that was built back to 1930s. That was using the federal money, so that's owned by the federal government. Then the TVA, the one purpose is just to manage that power plant and serve local user, even the user only just in Tennessee State, but that's still a federal company. Why I need to know? I don't need that anymore. But in the past, I need to identify which company owned by which government, because if you have contract working with federal government owned company, the paperwork is much more than any other company. So it will take much longer time to sign any contract. The largest first category, you can recognize some name, that is advisor-owned utility. So they can have they can be on the stock market. So they're not just for, they're making electricity for money, right? Definitely they are for the public good for everybody, but they're also making electricity for money. So you can recognize some name like AEP, American Power, American Electric Power, American Transmission Company, Con Edison. Con Edison is the power company of the New York City. Dominion Power. Dominion Power is in the Virginia area and also neighboring area. Duke Energy. So Duke Energy, Dominion Power might be the two large company the graduates from this department will work for. Okay. And energy is in the Louisiana state. There's a First Energy, Florida. Some name you can recognize the location, like Hawaii Electric Company. There's some company covering very wide area, like National Grid. National Grid is actually owned by UK, but they operate some power grids in the US. What else? All right, so that's first category. Second category is, the first category is for profit. Okay, second category is not for profit, but but usually they're owned by the local state or government agency, like New York Power Authority. New York Power Authority is a power company in charge of the area surrounding the New York City. So within the New York City, that's a consolidated Edison, Con. Outside of New York City, that's a NYPA. Okay. But if you are rich people, you live in Long Island, that belongs to Long Island Power Authority. Okay. So to do any business in the New York City area, you need to work with if you close to, if in Long Island, you need to work with LIPA, Long Island Power Authority, and also work with NYPA, and also you also need to work with the consolidated. They can be very complex. Okay. One story is I have recently working on a NYPA it's a project sponsored by NASA, but which look into placing the charger for electric aircraft or maybe electric vehicle, both ground-based and air-based. But they have interest in the New York City area. So they thought, I mean, transportation people thought it's easier, right? You just find the local, like suppose there are New York City power companies, they will provide the infrastructure and the map, and we can work on. But I told them, you are talking about working with 5 or more different power companies in order to give that map. Yeah. All right. So definitely there's an even smaller power company like rural farmers or communities. The last category is called, when we put it into other. One example is independent power producer or independent power provider. So what that means, if you have a large land, right? If in your backyard there's a hill, and on top of the hill the wind speed is very high, you may think about how about I build a wind turbine to generate electricity. So I just built a very large wind turbine. How about like 2 megawatts? And it's much more than I can use in my house. So I can maybe talk to someone from TVA. Maybe you can add a transmission line. I will sell electricity to you. So you will be independent power provider. Okay. You don't need the lines owned by TVA, by the power company, but you also become power company. You become the last category of power company, that's independent power provider. So back to 1996, there are not many independent power provider. Yeah, I cannot say not many, but it takes 11 to 12%. But now that number can go up very quickly because solar farmer or solar farms and wind farms grow very, very quickly in the past 20 years. Any questions? Right. So if you work on some projects on interconnected power system, you may often work with some power company such as like a PJM, California ISO, MISO, but those companies are not here. That's why they are power company, but they are not utility companies. In order to explain why we have so many different type of companies, we need to start with this concept, deregulation. So deregulation is complex concept to me. Why the first several years when I came to the US, I tried very hard to understand what it really means. Because in China, where I came from, definitely I know what regulation means, but I don't know what deregulation really means. But if we're talking about competitive US power market, deregulation is very important. Okay, deregulation means it's not dedicated for power industry. It can be utilized for any industry. But if in the power industry, we have someone generating electric power, and we have some user waiting for the electricity. So we need to send that generate the power and deliver power to the users. In the regulated region, if there will be only just one power company. All the users, let's say if Tennessee is a regulated power company, TVA is regulated power company, all the Tennessee people will need to get electricity, which is generated by TVA. But you don't pay the electricity bill to TVA. You pay through some other company. But anyway, so if there's a power company, they manage everything. We only just interact with that power company. So that's easier. You may think that simplify a lot of things, but actually that can give you increased electricity bill because there's no one to guarantee the energy, the efficiency. Maybe how do you know that company just intentionally just increase the electricity price, right? So there should be some competitive market to lower down the price. Then we need to enable this deregulation. So deregulation basically means the government only set down rules and laws for the market participant. The participant could be electric utilities, could be independent power provider, could be ISO. ISO will be the system operator. I'm going to talk about in a few minutes. And also there are some trading companies. Trading companies, they work for power company, tell you how you can determine your price and to give you the largest benefit. Okay, and so every company participate in the electricity market need to follow the law. Otherwise, you'll receive penalty or lawsuit. Okay, so there will be some company like as an example I gave. So if you have a wind turbine in your backyard, you will be a generation owner. You will be independent power provider, but you don't want to build any transmission line. You can work with the local transmission company. So the transmission company will provide the transmission grid. The grid is owned by transmission company. There are some companies that build both transmission, sub-transmission, or even distribution line. But some companies, they don't own any distribution. They only own the power grid above 100 kV. Okay, anything below 100 kV, that's not their facility. So there could be some other companies that own distribution network. So there will be owner of distribution network. And for distribution network owner, they will deliver electricity from high voltage into low voltage, but they can also work with some other company which are called service provider. The service provider that define any like a plan or meal for any customer to buy. So if you buy, if you sign the contract for a whole year, this is electricity price. If you sign just a short term, this is price. So that is all such things all defined by service provider. So you see, from electric generation until the end users, there are many participants into this market. And in some areas, some users, they can work with different providers, depending on which one gives you the best price. Or for some users, they can even choose between different distribution owners. Like for instance, in our area, we work with either KUB or ICUB, right? Definitely, to me, it's harder. I cannot just sell my house to move to another street if I don't like KUB. But for students, you are easier. You can just go to another apartment, right? They will use different power companies. Okay, so to make sure the market is operated in a healthy way, so there has to be some operator. The operator will manage everything. Okay, which is like a monitor for the entire market or for the entire system to operate safely. So that's called independent system operator. So independent system operator doesn't own anything of this grade. Okay, they're only just operators of the grid. They are going to determine the electricity prices using a bid-based security counseling economic dispatch. So if you learn economic dispatch, you maybe know what I'm talking about roughly, right? For instance, in 421, we talk about economic dispatch. But here the difference is we need to consider some security constraints. Security constraint will be like equality or inequality constraints. You need to satisfy and to minimize the cost function. Bid-based, I will explain what bid-based means, but basically, I also need to solve the economic dispatch problem to determine the electricity price. So if it's a day-ahead market, so they need to determine the nodal price. the price at each node or each bus, each area, each zone, by matching the offer from a generation owner to the bids from a consumer. Okay, so if it's in the same regulated power company, the power company can do the like a load forecasting based on how much demand for each, maybe each hour. So they can minimize the cost by dispatching all the generation, right? And also definitely the power company need to also gain some profit to support its operation, but the price can be pretty much determined. But in the electricity market, the demand of customer is not steep, actually soft. By soft means there will be a curve. Okay, so if your electricity price go down, I will use more. If you go up, I will use less. So there will be a curve. And also each generation owner also provide a price curve. If you ask me to generate more, I will give you a higher price. If you less, I can give you the lower price based on my fuel cost. So there will be two curves. The two curves have to intersect. And that intersection point will be the equilibrium of the market. So that's determining the final price. So the concept locational marginal price is exactly the price describing the one area. So if you have a nodal price for different locations, so you can calculate the weighted average for all the prices and give the price for each zone. Okay. So the real-time market establishes the real-time locational marginal price by balancing the differences between the day-ahead commitment and actual demand. We don't go to the details. If you have interest, you can take a 522 or 622. They will cover more about the power system economics. Okay, so this map just shows the existing system operators. So those operators use different colors. They are also power companies, but they are not utility companies because they don't own anything. For instance, from the map, the largest company seems to be the Mid-Continent Esso. Okay, and another company, the PJM, is also a large area, large power company or large ISO. And the New York ISO is a system operator for the New York State. So in the rest of the New England region, that's called New England ISO, ISO New England. In the Midwest, there's a Southwest Power Pool, SPP, and Texas itself is operated by one company. It's called ERCOT. And California operated by one operator, California ISO or CAISO. So California was the first state to implement the food deregulation. That back to 1999, 1990. Also, the map shows some operator from Canada, like the Alberta has a system operator, and this is Ontario also has system operator. And sometimes some utility company from Canada also join operator from the US. Okay. So this figure is from 2015. If you can search for similar figure back to the 2012 or 2011, the first time when I taught, the color are different. Okay, the territory are different. So in that figure, this part, if you see the MISO pretty much split it into two regions, and there's a very narrow path connecting the north and the south area. And before this time, this part belonged to SPP. It doesn't belong to MISO. And at that time, the MISO is not called MISO, it's called Midwest ISO, because it only operates the Midwest area. And this company is pretty much Entergy. If you go back to the early slide, there's one power company called Entergy. Where is that? Yeah, here. Entergy, also some neighboring company, they in the past, they operated by SPP, but they joined the MISO. draw a midwise ISO. The midwise ISO become meso. Okay. So what are those system operators are? So if you have any chance to visit any office of those companies, they pretty much just a building in the plaza, and they may have for example, using the California as one example, they may have 700 employees. If you do the math, assume maybe the entry level salary and the senior level salary, pretty much the operation cost about $200 million per year for each asshole. So the power company, other utility company will be members of those system operators. They pay the annual membership, so they have you to coordinate among those utility companies. Does anyone have project working with any of those companies? No. So you have not been senior enough. Maybe in the last 1 or 2 years, you have to work with some of the companies. Okay, so this slide gives you an idea on how the economic effect is used to determine the price. So let's consider maybe a very simple example of a power system with 3 power plants. For each power plant, so it has fuel costs to generate electricity. The fuel cost usually is a nonlinear function because if it generates more, the cost will go up. When we try to find the equilibrium for the market or for the economic effect, we're interested in the incremental cost. Incremental cost is just do the first order derivative of each cost function with respect to its generation. So if we assume the fuel cost function is a quadratic or second order function, so the incremental cost will be pretty much a linear function. So we can draw those 3 linear functions in the same chart. Okay, so the slope will indicate how quickly the price can go up. If the unit is very expensive, the slope will be higher, will be bigger. So for example, if we want to use the 3 power plants together to generate 800 megawatt power, so we just need to we calculate first order derivative. Then we draw these 3 straight lines. Okay, then we draw a horizontal line, and we just move up or down of this horizontal line until the 3 intersection points tell you the number, the total they make 800. That's how the economic effect is done. I assume most of people familiar with. I'm talking about the geometric way to solve the problem. You can definitely do the math. If you like to work on the equation, it's okay. But this is the very visual or geometric way to understand this problem. So if the load increases, this line will move up, and all the intersection point will move up, and the generation output will increase. Okay. So, but when the line reaches any limit, okay, when I further move the line until it reaches the limit of 1 unit, it has to stop there. That generator cannot further increase. So that limit is 450. So, but you can further increase other 2 units. And definitely, those 3 points you add together about the power that tell you how much load, how much maximal load the 3 generators can power together. So if the 3 power plants are owned by the same company, okay, I can play with the bidding. If I was talking about, I can assume those 3 lines tell about the actual fuel cost. Okay, but if I think this, for example, this unit, this unit is not safe to operate under this condition. I can shut down this unit. If I shut down this unit, the other two units will have to generate at the maximum value. So for example, this unit need to generate 350 and the third unit need to generate 450. So it together can still give me 800, but they will operate at much higher price. If you want, you can calculate all the combination. Let's just use 800 megawatt as the load. You can compare this using 2 units with the first 1 unit outage, or use all the 3 units. The cost may be different. So which means the power company can gain money by maybe choosing between different strategies. So now if each power plant owned by different companies, and even the fuel cost curve provided by those the company can be programmed, can be changed. They don't reflect the true fuel cost. So there will be a risk, right? So there will be some uncertainty to match the bidding from the user and also the price from the power company. So soon after the California started the full regulation, something happened, which is called California electricity crisis. That's happened from like 1999 to 2001. So if you have interest, you can find that journal paper. So that helps describe how this one happened. Okay. In order to explain this event, I have to introduce some background about what we call the stage 3 rolling blackout. Rolling blackout means I can shut down my power plant. So if there's any emergency, any like a hurricane or tornado, sometime in order to protect the power plant can be shut down to save the power plant. Definitely you lose this power plant, you also lose the generation. Some user need to be also lost. But power company has the right to select when to shut down power company, as long as they believe it's necessary. One category is called stage 3. Stage 3 means if they believe this power plant is not safe to operate further, so they can shut down. They can do like a maintenance. Before deregulation started, there was only one stage 3 rolling blackout in that area. But quickly after passing that law about the deregulation in California, so there are many, like 38 stage 3 rolling blackout. What I mean is the power company said, okay, so my system has some weakness. I need to shut down this power plant, do some study, but then they will shut it down. So once they shut it down, think about the previous slides. You have your generator change from 3 to 2. And for the remaining 2 generator, you can price much higher than before, right? So that can give you more money. So that was encouraged by the traders or marketers. They try to teach the power company to intentionally do this rolling blackout to shut down some units. Then they can sell electricity price at a much higher level. Okay. So on one day, which was July 13, 1999. If we check the 3 hours, like from 12 o'clock, 14 o'clock, and 16 o'clock, if we try to draw the demand curve, the supply curve, and we will see how the equilibrium change. Even the 3 times all stay in the same time period for peak load, but the price change a lot. Actually, the price is become triple within 4 hours. So in this chart, X is the total this is megawatt hour, which is total energy, total demand of the load. And the Y is really the price. It's $1 per megawatt hour. Okay, so there are 2 types of curve. One curve is monotonically going up. Okay, that's supply curve. Supply curve, you can consider supply curve will be similar to the fuel cost curve. So if you generate more, the fuel cost will go up. It's like a quadratic function. The demand curve is demand by user. So if the price go down, I will use more. If price go up, it will use less. So that's why it will have a negative slope. Okay, the two curves intersect will determine the equilibrium. For instance, at 12 o'clock, this green dot was the equilibrium. Okay, so if you check the price, that's a $50 per megawatt hour. And then the company intentionally did the state street rolling blackout. So that quickly increased the supply curve going to this one. And also the demand also increased. So finally, the equilibrium become that red dot. That's 3 times of the regional price. Okay. So if the power company play with the market and intentionally to shut down some unit and increase the price, and also the load also is growing, so the price can change significantly, but within very narrow time, very small period. So later, the market law was revised and also try to eliminate such a crisis in the electric market. So this is one example that show if we do deregulation. The idea of deregulation is to lower the cost of operation, but actually it increase some reliability uncertainties. So we do need to have some reliability criteria to ensure the security or reliability of the market operation of the grid operation. Then we need to talk about the NERC. NERC is a company called North American Electric Reliability Corporation. First of all, it is not a government organization. Okay, it's formed by electric utility industry back to 1968. 1968 was 3 years later after the first large blackout in the northeastern blackout in 1965. So this organization is to promote the reliability of block power system. So I will explain what this one really means. Okay. So the initial membership was volunteer. Once they join this organization, all the power companies, they need to follow the reliability criteria. So there will be a criteria for planning, criteria for operations. They try to prevent a major disturbance of grid. Starting in 2007, FERC is the U.S. Federal Energy Regulatory Commission, granted NERC the legal authority to enforce reliability criteria with all users. So the membership of NERC become mandatory. So if you power participant of the power industry, either your utility company or you can be a system operator, you have to be member of NERC. You have to join the membership of NERC, and you have to meet all the requirements, all the criteria from NERC. And if you violate any criteria, you will be fined. Okay, you need to pay penalty. You can pay a lot of penalty. As a member of NERC, you can participate in their working group to develop a new standard or discuss about how to change the existing standard. Once a new standard is developed, it will take maybe several years to collect feedback or comments from the entire power industry. And if all the discussion is stabilized after maybe a few years, it becomes standard. So that's a process. So if you have interest, you can go to NERC.com to see their existing standard, which means they're already published standard, or there are some standard under development. Okay, so if you click into those under development standard, they're not called standard, they just called some draft standard. You can see there's a lot of version 1, 2, 3. They have many discussions. So a lot of discussion is really change back and forth about that single word. Because if you add that word, that will maybe increase my responsibility of my company, but lower the responsibility of your company. So there will be a fight. There will be a fighting between different companies. Finally, they will try to find the best compromise between all the companies. Okay, so we need to explain what the bulk power system or BPS or bulk electric system means. So there are two names often used by either NERC or FERC. So FERC typically used BPS and NERC typically use BES. BES just the original definition came from the Energy Policy Act of 2005. So if you go to find that act, you will find this sentence. The BPS means facilities control system necessary for operating in a connected electric energy transmission network or any portion or thereof and electric energy from transmission facility needed to maintain transmission system reliability. So if you just read through this sentence, you basically don't understand what it really means. But definitely that's like a legal language. It has to be very accurate. But definitely the BPS is a term used usually just about interconnected network or power grid. Okay, so that is what power industry is looking at when we about interconnected power grid, interconnected power system or power grid. That's a more accurate terminology for power grid. Okay, so BES is defined by NERC. Usually that very close to BPS, but maybe more accurately speaking, that's at least included by BPS. So BES is defined by NERC. The definition is the electric generation resources, transmission lines, interconnections with neighboring systems, and associated equipment generally operated at voltage of 100 kV or higher. Okay, you can simply just remember the BS in such way. So for power grid, it has power plant. They have a transmission system. They have a sub-transmission system. They have diffusion system. But you need to include the generations, transmission system, and the sub-transmission system higher than 100 kV. And that part is called BES. Okay, lower than 100 kV. In the diffusion system, that's not BES. But if the generator is operated lower than 100 kV, but it belongs to generation, that's BES. So it's a generation plus transmission and sub-transmission system higher than 100 kV. It talks about the major, the backbone part of a power grid. So if you want to ensure reliability of the entire power system, if you can make sure the BS is reliable, very likely the whole system will be reliable. Okay, because the BS will have more strict standard of reliability. Any questions? All right, so this is the map we have seen about the system operator. System operator, the original purpose is just to manage the electricity market. If you have a fully deregulated market, you need operator to manage the electricity in that area. But in some area, if you don't have a deregulated market, actually not every state in the US has color area. It's operated by some independent system operator. Like Tennessee is white, right? It's not operated by any system operator. But it doesn't mean it's not operated by some company. So the first map only indicates where the deregulated market is. But if you don't have a fully deregulated market, you have a regulated power company, that's fine. But you still need to meet all the reliability standards, even you don't have fully deregulated market. Yeah. Then maybe such statement can be a little bit confusing, right? So when you say deregulation, it doesn't mean you have to deregulate yourself. You can choose between either deregulation or regulation. That's called deregulation. So if you choose not to do deregulation, fully deregulate, that's fine. Which means your local people are happy and with electricity price. For instance, we are not in a fully deregulated electricity market. We operate by, our power company is a TVA. But what is your electricity bill? What's the electricity price? Does anyone know? I mean price. Yeah, about 10 cents per kilowatt hour. Okay. So do you think that's high or low? Huh? You think it's low? Yeah, pretty much. If you represent the majority of the Tennessee people, you're pretty happy with what TVA is doing, or TVA, KUB, or SUB is doing. Right? It's not a problem at all, right? Regulation. But if in some other area the customer like to have even lower price, or maybe their price is double, they may want to the more welcome for the deregulation to lower the price. But deregulation doesn't really mean it will necessarily go up, decrease the price, because I mentioned in order to have system operator like California ISO, they hire like 700 or 800 people, and their operating costs like 200 or 300 million dollars. So if you want to pay that price, operation cost, to help you lower the price, okay, it's up to you, right? So which means we don't have independent system operator everywhere. Yeah, you can vote. I don't know. I mean, you can vote. You can vote the governor. The governor will, let's see, let's do it directly. Oh yeah, that's really hard question. Then to answer that question, you need to go back to the entire history of deregulation. Yeah, I can only say that's what it is right now. Yeah, but it may be much easier you just move to another state. Let's see, you move to the PJM. You just drive like 4 hours, go to the PJM territory, you enter the deregulation. Okay. Okay, so that's only about the market. But in the white area, we do need someone to enforce the regulation in terms of reliability, not about market, but we do need somehow some type of regulation or some enforcement by NERC to guarantee the reliability. Then we do need some operator, but we don't call such company operator, we call them coordinator. So there are some companies in those wide area, they are operators of that area, but they're not market operator. They're not independent system operator. They are reliability coordinator. That's better name. But for the regions like PJM, they already have independent system operator. It's very naturally that independent system operator will be the reliability coordinator. Okay. So this is how the NERC define the regions for the entire, actually it's not just for the US, it's for the entire North America. Because they understand different regions have different situations, different concerns. So it's not smart to define just single set of reliability standard, right? Ask everybody to satisfy. It's better to partition the entire North America into a different zone. So now you see the entire North America has 4 zones. A better name is called interconnection. So each interconnection means 1 AC power grid. So within that section, everything are connected through AC. Okay. Across the interface, there's no AC line, only the DC line. Very weak DC line, not strong enough. So pretty much you can ignore the interconnection between those 4 regions. For the entire western side, that's called WECC, right? That usually is called Western Connection. WECC is a brief name for Western Electricity Coordinating Council. So there's a coordinating council determine the set of criteria that the region needs to meet. Okay, the total generation back to 2009 is 180 gigawatt. It takes about 19% of the peak load of the entire continent. And the Texas itself is interconnected, doesn't connect to any other neighboring state. It's operated by ERCOT, so you can call it ERCOT interconnection. The load is only 70 gigawatt, takes about 7%. The largest connection is called Eastern connection. You see many different colors, which means that interconnection is too large. Only having the same coordinating console is not enough. You need to define many different consoles. So each console will set up one set of reliability criteria to meet. Okay. So for us, for Tennessee, we belong to the green area. The green area is Southeastern Electric Reliability Council, or CERC. So what council means? Council means it's not a company. It's just loosely connected organization, participated by all the power industry people in that territory. They just regularly meet and just define the reliability criteria to operate the system. So Eastern connection takes like 70% of total load of the entire continent. So in Canada, so the Quebec province itself is operated as interconnection. Even it's usually they join the NPCC. NPCC is called Northeast Power Coordinating Council. So NPCC has a meeting including the Quebec province, but Quebec province has no AC line to rest of the system. So itself is operated as one connection. Okay, so by looking at this figure, it's not good, not accurate if you see a US power grid. There's no such US power grid. There may be full AC power grid in North America, okay? And including Canada, including some of the Canadian provinces. But we have a full interconnection. The two largest connection will be the Western connection operated by WEC, or the Eastern connection operated by many reliability councils. Question?
What determines the reliability at these boundary lines?
Yeah, that's a good question. So if you see another figure, you check the boundary pretty much same as the territory of the power company. So as I said, so each color region is not like a tightly operating company. It's just council. A council means like a graded council, like faculty council, right? We regularly meet. We meet maybe monthly, bi-monthly. We try to update the rules. You can think about the NERC has one set of reliability standard, but reliability standard may not be applied to every single company, but may be applied to the company from the same area. So if a TVA and a Southern Company and other power company together, we form this council, we decide which rule we need to follow. Then we naturally draw that boundary. So if there's a small company just on the boundary, you can decide either you draw that council, you draw the green council, the blue council, or you want to draw both. Right? It's okay. Yeah. Then you decide which one you really want to satisfy. So this is like a more confusing map, right? That indicates all the reliability coordinators. As I said, every region need to be operated by some reliability coordinator. Okay, so that reliability coordinator can be independent system operator if you are located in a fully deregulated market. Otherwise, they need to be operated by the local transmission company, like a TVA. This is TVA. TVA is the reliability coordinator. But if you compare this territory, is different from the TVA region, or different from Tennessee State, which means in surrounding the Tennessee State, there may be some other utility companies, they also operated by TVA in terms of reliability. Okay. Below TVA, there's the ISOCO, that's a Southern Company. Southern Company, if you check that the system operator map, that's also white. There's no independent system operator. But Southern Company itself is a transmission company, so they can operate the system. There will be a reliability coordinator. And for some area like the ERCOT is a system operator, so it will be a relative coordinator. And SPP is a system operator, so it becomes relative coordinator. But this map and compared to that map are not exactly matching. Okay, there may be difference, which means some small companies may draw relative coordination by this company, but not draw the market of this company. It may draw a different market. Okay, so that's why the North American power grids probably the most complex power grid in the world. Any question? Yes.
Also do that with the nerd, or is it different?
Yeah, I think this part is from Mexico, right? I would say partially. Yeah, you can definitely check. Maybe to figure out that answer, you just go to WCC. Should be WCC or go what company. So yeah, just go to WCC, go to website to see all the participants of that council and identify the utility company from Mexico. This is a mass map, which is called balancing authority. Balancing authority means each region on this map has to be balanced between the generation and load all time. So that's why, so this map will define even smaller area. For very large area from previous slide, if that's too large, so the distribution of generation load may not be even, so they want to split into a smaller area. So you see each bubble in this map, that bubble means the center of the balancing authority. And that balancing authority need to be located somewhere, some control room. Like for example, the TVA here on this map become orange. TVA itself operated as balancing authority, which means within that territory, the total generation, total load need to be same every hour or maybe all the time. Okay. So there's some if you compare this map from the previous map, the shape of the territory are not exactly the same. Okay. So each balance authority has to meet their own load to maintain the balance between generation and load. And here, the generation doesn't have to be the real generation; it can be purchased generation. So when that area defines balance authority, but the actual installation of the power plant may be much less than the load. But it's okay. You just need to sign the contract, maybe the B, to buy the electricity from your neighbors to meet that balance all time. That will be fine. So that purchase electricity also considered as your generation. And you definitely can sell your load to the neighbors. Then that so that amount of load will also consider load. So which means within each balancing authority, the generation and load may be from your neighbors, not necessarily local.
Why does Florida have so many different authorities?
Yeah, one reason is there are many local companies. They can take care of the local balance. That's one reason. Okay, so like TVA, like Tennessee, they're just one company. So which means the TVA has more freedom to decide how I can shape the generation from west to east, and as long as I maintain within that boundary all time, the load is balanced. Okay, but if you do have many small companies, they each can take care of the local balancing, is fine. Yeah, each balancing authority has to be
operated by someone, an operator sitting in some control room. So if a TVA itself is balancing authority, that operator managing the balancing authority need to sit inside of the TVA control center or control room. And for Florida, there are many small companies, and each bubble need to be monitored by someone sitting in some control room. Yeah, there may be many control rooms managing the balancing in that area. Okay, yeah, this is just figure from the IP dynamic tutorial. So it just there's a very good section to talk about the balance authority. So did everyone download the dynamic tutorial from IP? If not, just do it today. But that sounds new to you? Okay, so I mentioned there's the main textbook is Quinder Power System Stability and Control, right? And we're going to do some homework from Sadai's book, Power System Analysis. The third one is free. PDF, you can download that one from IP website. Yeah, so that gives you a lot of introduction about the background information such as balancing authority. So it's assumed there's many balancing authorities that connected through transmission grid, and on the boundary of each balancing authority, you may have meter. The meter will measure how much power in and out. So that need to be same as the plan based on the electricity market. Okay, so this is my last slide for this lecture. So it just gives you an idea on what the control room looks like. Control room typically will have the entire wall as screen, LED screen. So you can show the map of the grid. They can show some very important, like meter that indicate the safety margin away from the limit. And inside of the hall of the room, so you can see a setup of many tables, many desks. So usually each set of desks only have one person checking all the maybe display or check the result. So there will be usually a rotation of 3 groups of people. So each group operates for 8 hours. For example, I don't know. I just actually say maybe this guy is just operating generations, and the bottom guy may be operating some maybe market, and maybe the guy in the front maybe operating the transmission grid, right? So each group of table that only have one operator monitoring the entire system. So those operators, they don't do simulation, okay? The operator, they are not engineers. They are just operator. Operators like a driver of a car. They don't know how to repair the car. Technician, they can repair the car. So usually, so if you write a paper, if you write your paper and say, okay, so my method will help operator, operator can use my method to do analysis. Operator don't do analysis, right? They just operate the grid. They do need to, they're very good at understanding all the standard and how to interpret the standard and to make the system safe. That's their job. But there could be a task. There's a person which is called operational engineer. They're called operational power system engineer. So their job is they're engineer. They can run all the simulations, they do the study for operator. So if that operator said, please do this study, maybe run this list of contingency for me, and that guy need to do that study. So some power company, they have such engineer sitting in the control room. Some will maybe sit in the same building, but not in the room. All right, so on Thursday, we'll talk more about reliability standard. Okay.